Okay. All right, so notebooks out, we ready to go?
Yep.
All right, so today we're going to be talking about proportions. Proportions look like a fraction equal to a fraction. Okay, whenever you have a fraction equal to a fraction, you're dealing. Okay, gentlemen. Okay, so the process of solving a proportion is pretty straightforward. Okay, first of all, if you can reduce the fraction that doesn't involve the variable, just the fraction, you should reduce the fraction if you can. Okay, and we'll do examples like that in a moment. To solve it, use the same process each time. You're going to cross multiply. Okay, entire thing, and this 5 is going to come up and multiply that entire thing. Okay, so 5 is 25. Okay, and at this point, we're back to where we were dealing with all of the solving equation stuff from the other day. Okay, so you're going to distribute first. Thank you. Okay. Now you're going to solve for the variable. So we're going to move everybody around. Okay. So move the 25 over. Move the 6 over. Bring the 30 down. What's 25 minus 30? 5. Notice something. Your answer is not going to be a whole number most of the time. Okay? Remember, you divide both sides. Now, normally we leave the negative sign up top. The negative sign up top. That's just like this fraction can be reduced. You reduce it. If it's not reduced, I'm going to send it back to you. Okay? Always, always, always reduce your fraction. Okay? So let's do a couple more. We're going to show you some of the different things that can pop up. The algebra isn't that bad. It's just kind of, 1, 2, 3 steps. Nothing too big. Okay, it's the same 4-step process we always do. Distribute, move, combine, divide. Okay, that's going to stick with it. But your answers, most of the time in this, like I said, are going to be fractions, and you're going to have to make sure that they're reduced all the way. Okay, so let's do this one. Right. When you see a negative sign in front of a fraction, that negative sign is talking about the top number. Okay? You don't want to put it to both numbers because then it would cancel out. Okay? And we don't want to do that. There's one negative sign, it's going to move. You can just go ahead and rewrite it if you'd like, because that's and that is true always. If you have a negative in front of a fraction and you don't have gum, thank you so much. The negative goes to the top. So now we cross multiply. So 7 times 3, 21. For multiplication is going to, and don't forget your parentheses, people. Okay? When you're multiplying to a binomial, that's what that's called. Bi meaning 2. Okay? When you're dealing with something with two terms and you're multiplying against it, you wrap it in parentheses. And now it's distribute, move, combine, divide. Negative 8 times k. Thank you. It's negative 7. Negative times a negative is a good 50. Now we move. 21, stay or go. Goes and becomes negative 8k over here, stay or go. Goes and becomes positive. It switches signs. Okay? And 56 minus 21, 35. I don't hear everyone on this one. Why is it positive? Yeah, the positive is bigger, right? The positive number is bigger than it, so it's going to be the one that leaves its sign on it. Okay? And now we divide. Can this fraction reduce? No. Okay? And one of the things that you can ask yourself is, does it reduce? Is you can say to yourself, is there a multiplication table that I can imagine that has both of those numbers on it? Okay? We've seen the 8 pop up on, obviously, the 8's times tables, but what other times table do you see 8 on? 4's and 2's. Okay, good. What about 35? Where do you see 35?
5.
You see it at 5, and you also see it on 7, right? There's nothing that's common between them. 2, 4, 5, 7, nothing that both of them have, so you can't reduce it. One thing that you can always ask yourself is, are both numbers even? If they're both even, then you can reduce it at least by 2. Okay? Sometimes you can reduce it multiple times, okay? And simplify it all the way down as far as it can go, okay? All right. All right. Let's do some examples here. Let's do this one. Here's some things that can maybe make your life a little easier. Well, first of all, what am I going to do immediately, right off the bat? What do we notice that we have to deal with? The negative sign. That negative sign out in front goes where? Up or down? Why not both? What would happen if they was on both? Yeah, they would cancel out because a negative over a negative is a positive, and that's not what we want. We want it to be a negative. So this guy right here, we're just going to put him up top, right? Okay. Do we notice anything else that we can do to this? Maybe make it a little easier? Deal with maybe smaller numbers? What can we reduce? Yes. Reduces. 3 over 6 reduces. Because both of those numbers are on what times table?
3.
Well, 6 is on the 2's, but 3 isn't. But they are both on which times table? The 3's times table, okay? 6 is on the 3's times table, and obviously 3 is on the 3's times table, and neither one of them have gum either. Thank you so much. So, if you reduce, it would be okay. But I think it's easier to work with smaller numbers if you can. If you deal with smaller numbers, that's great. And also, at the end, you're not reducing big numbers. You're going to have to reduce somewhere. If either at the beginning or you do it at the end. If you do it at the end, you'll still get the same answer, but you're going to have to deal with big. You can't reduce first, reduce first. Okay. All right. Now, this 3x minus 2, I'm multiplying all of that times 1, right? Do I have to bother now? Do I have to deal with that? Because it's multiplying by 1, right? And you see, because I reduced, it's a 1. Before it was a 3. And if it was a 3, I would have had to distribute, right? But by reducing, I don't have to distribute now. It's easier, you see? That's good. So now I can just write 3x minus 2 equals, what's the other side going to look like? Negative 4. Why isn't it 0? Because you're multiplying, you're not adding, right? This is cross multiplication. Okay, so we're multiplying, and we get negative 4. Now the 3x is already where I want it to be, so all I have to really care about right now is the negative 2. That's not in the right place, so we're going to move him over. Negative 2 comes over and becomes a positive, and the negative 4 stays. It just comes on down. We combine 2 minus 4. Negative 2, right? And it's negative because the 4 is bigger, right? And when I divide both sides, what do I get on the right? Negative 2/3, right? That's why. Oh, were you asking a question or are you giving an answer? Okay. All right. So if you can distribute, please do. It'll make your life easier. And in this case, we didn't. It saved so much work. We didn't even have to deal with distribution or deal with bigger numbers and bigger subtractions and stuff like that. Okay. So keep your eyes out. Let's do another. Now I'm going to show you a trick that you're not going to see very often at all. Here's a fantastic trick. I'm going to find a good example. Here's a great example. You guys know that you can reduce fractions up and down, right? You know, divide both the top and the bottom by the same number. Well, I'm here to show you that you can not only reduce up and down, but you can reduce side to side. Yeah. See this 8 and this 4? I can reduce those sideways. How do 8 and 4 reduce? By 2, but even better. By 4, right? They're both on the 4's times table, right? So if I divide 8 by 4, I get 2. And 4 by 4, I get 1. And now I've got a nicer problem to work with. And you see, again, I don't even have to worry about distribution now because I'm multiplying by 1. See how that made it easier? Finish this. Nice. Yeah. Everyone getting 4 over 7? Yep. Fantastic. Okay. Now, if you didn't reduce sideways, which is fine, it's just going to be, you don't have to copy this one down. Just notice that when we do it the long way, you should still get the same answer, but there's more involved. Take a look. We use the right now. You see, there's a lot more work in there. I have to reduce it 2 times. Because maybe you don't notice that 4 is the number you can reduce by, but the fact is you still get the same answer. So don't worry. But so if you don't notice right away that you have to reduce, no problem, do it later. But it's gonna make it a little bigger. Okay. Let me show you something you cannot do. Here's a mistake I see often. All right. You cannot cancel added terms. This does not work. No. Cannot cancel added terms. Tattoo that to the inside of your eyelids. Cannot cancel added terms. You do not know how many times I see that happen. A small piece of my soul cries. Okay? No. Hmm?
I almost just did that right now.
Oh, goodness. Cancel added terms. Instead, can I reduce anywhere? Can I reduce up or down or side to side? Anywhere? No, not in this one. So I just have to do the straight multiplication. See how I cross multiplied there? The 4 came up and multiplied both of them, and the 5 came up and multiplied the 3. Wrap that whole thing in parentheses. It's a good way to not make a mistake, is to wrap the binomial in a pair of parentheses and then cross multiply. Okay? Finish that one. Hopefully we'll all get the same answer. Seeing pencils slowing down. We almost done? Hopefully we all got that. You good? Watch your signs, guys. One, we're ready? All right. Can we reduce? Where? Which 6? Okay, let's reduce the left hand. What's the left hand side going to reduce? They're both even, right? So we divide them both by 2 and we get. Are we ready to go, or can we do anything else? Huh? Where? Remember, you can't cancel up and down. Well, you can't cancel when the terms are added up. Like, oh yeah. You're not allowed to touch. Okay, we'll deal with that kind of stuff later. Yeah. Which one? The 6 and the who? Oh, no, you can't cross simplify. No, you cross multiply. You simplify up and down, and you simplify left and right. Yes. The 4 and the 6. I can reduce sideways here. See it? And what do they become? What does the left-hand side become? A 2.
Three. 3/2.
And what does the right become? 3. Now we can cross multiply. We could have cross multiplied in the beginning, and we still would have gotten it. You don't have to reduce. But if you don't reduce, you're definitely dealing with bigger numbers and more work and bigger chances of making a mistake. So try to reduce, just as good practice. Okay? So try this one now. All right, so 3 times 3. And what am I going to do with this? What does this become? What should I write down? Good. And now we can distribute, right? Two times 7, negative 14, very good. Okay, now some of you are more comfortable at this point than others. For those of you who are comfortable here, yeah, we can move the 9 and the 6 and deal with that, but that's going to give me a bunch of negatives. And I know some people would prefer to deal with positives if you can. Okay. One thing you can do, remember, you just want P alone, right? The whole job is to get P alone. Why don't we just move the 14? And then the P will be alone. See? It's, you don't have to have letters on the left. You can have letters on the right. It's up to you, especially when the problem is really small and you've only got to maybe move one thing. Sometimes it's easier to just move one thing than to move a whole bunch of things. Okay? And now what does this become? 9 plus 14? Divide, should it be, is P 6 over 23 or 23 over 6?
Oh, 3 or 6.
You want P alone, right? So the 6 has got to go away. It's the 6 that it's supposed to be. You want the letter alone, right? So divide both sides by 6. And now. Okay? Always divide the number away from the variable, okay? Whatever direction that means, you're trying to get the variable alone, so push everything off of it, okay? So that it stands alone. Does that make sense? Okay, you guys about ready to get started? Yes, question.
When you don't put the letters on the left side, they
Yeah.
get negative.
Why? Wait, if I
Because the 9 goes to the 14 of the outside. It's going to be
well, if we did move it around, move the 9 over, it becomes a negative, right? Move the 6 over, it becomes a negative, and this is still a negative. Now the 9 and the 14 are still going in the same direction, but this time they're going to the left, they're not going to the right. So they still add up together, and I still get 23, but this time it's negative. And now negative over a negative makes a positive. Okay, do you see that? So it's still the same no matter what. But my advice to you is to reduce whenever you can. Okay? You cannot cancel, you cannot reduce through addition or subtraction. Okay? Addition and subtraction do not get canceled. Okay? Leave that alone. But you can reduce anything else if you want. Okay? We good? Fantastic. This episode of The Ronco Show has been brought to you by cross multiplication and the number 4.